Hello everyone, back with another video, and this is episode 3 of Love JavaScript series. So if you haven't watched the previous episodes of Love JavaScript series, then I would highly recommend that you should go through those videos, because those videos are going to clarify most of your doubt related to call stack, global execution context, multiple execution context, and I have taken an example and explained line by line that how those programs get executed by JavaScript. So before starting this video, I would like to introduce myself. As I said, I am Satyendra. I am a software engineer by profession and electronics engineer by degree. So what would be the content of this video? So the content of this video would be, we will be talking about the JavaScript engine, internals of JavaScript engine, and we will be talking about the event loop, callback queue, microtask queue, and also we will be going through the popular Google's V8 architecture. So Google's V8 architecture is a part of a Chromium project that empowers or provides the JavaScript engine to Google Chrome browser and also the Node.js browser. So this video is going to clarify most of your doubt related to JavaScript engines, and you will see that how a particular program will be executed inside the JavaScript engine. So I hope you will going to enjoy this video. So before diving deeper into the JavaScript engine, internals of JavaScript engine, first we need to understand what is JavaScript runtime environment, right? So JavaScript runtime environment is nothing but a piece of code that is being developed by a developer like you and me, which helps to execute your program, right? So this JavaScript runtime environment could be provided by the browsers, it can be provided by the servers, or it can be available in the IoT devices like a smart watch or a smart fridge or a smart oven. So JavaScript is like everywhere, it is present everywhere. It can run in the browser, it can run in the server, it can run in the IoT devices. So in the browser, how this JavaScript runtime environment works, right? So if you see, so in JavaScript runtime environment, basically we get the JavaScript engine. That JavaScript engine helps to execute your high level program. So in case of a browser, first we need to understand what are the engines that are available. So popularly for Google Chrome, we are having the V8 popular engine, and this JavaScript engine is also being utilized by the Node.js for the server side programming. Now for Mozilla Firefox, basically we are having an engine called SpiderMonkey. Now in case of Microsoft Edge, we are having Chakra engine. So these are some of the popular JavaScript engine which helps to execute the high level program, right? Apart from that, in JavaScript runtime environment, we are also having some APIs. So in case of the browsers, like if you see over here, so in case of our browsers, we also get some web APIs. What are these APIs? These APIs are not basically part of the JavaScript engine. Basically it is the part of the browser or the browser specific runtime environment. So these web APIs can consist the API related to HTTP request response. It could be the DOM APIs, or it could be a Canvas APIs, right? Canvas APIs, or it could be the set timeout related APIs like set timeout or set interval, right? So these APIs are being provided by the JRE inside the browser. So these web APIs will not be available inside the server side. Like for an example, if you are running the Node.js, though Node.js also utilizes the V8 engine, but you will not get all these web related API. The APIs there, like a file upload, file system, all those APIs will be available over here. Apart from that, we are also having this callback queue. I will explain in detail that what this callback queue is there, and there is a event loop. Now this event loop interact with this call stack as well as this callback queue. Now let's go into a little bit more deeper and understand inside the JavaScript engine. So what is there inside the JavaScript engine? So inside JavaScript engine, basically there are two major components. First one is the memory or a heap, right? So whenever you write any JavaScript program, so it first goes through the memory creation phase. memory creation phase. In this memory creation phase, the memory allocation for the variables, objects and all happens, and that happens or taken care by this heap, right? What is the call stack? Call stack is that, if you haven't watched my second video where I talked about the global execution context, and call stack, then please go through that. There I have taken an example and I have walk you through that how that program is getting executed, how multiple call stacks are getting, multiple execution contexts are created, and how that gracefully handled by the call stack, right? So whenever any function invocation happen, the execution context is getting created, and this execution context will be pushed inside this call stack, and after that execution context will be popped out from the call stack and it will be destroyed or the deleted. Now let's say you have make a program, suppose you are a front-end developer and you have wrote a program where you are interacting with the web APIs, right? So the execution context that will be created related to the web API first will be pushed inside the call stack. After that it will be migrated or popped out and put inside this web API container, right? So these web API container, for an example, if you have written a set timeout, you have used set timeout and there you have provided a delay of 3 seconds. So let's say if that function will be here in the call stack, but that function is supposed to be executed by 3 seconds later, right? So what it will does, if it will go in the call stack, it will block the execution, right? So only after 3 seconds the next line will be executed, but JavaScript does it very nicely. So what it does is that if non-blocking code is there and it's related to web API, it will be pushed inside this web API container, and after that 3 second delay is over, it will be pushed inside this callback queue, right? So this callback queue will basically take the task from the API, and this is the event loop. What is the main logic of the event loop over here is that it will constantly monitor that what is inside this callback queue. So it will take the task from the callback queue and check whether the call stack is empty or not. If the call stack is empty, it will take the task and put inside the call stack, and after the execution of that execution context, then that will be again popped out and it will be implemented. In this way JavaScript gracefully runs your program. Now in next slide we will be understanding the top level view of the JavaScript engine, which is very much important, and that engine is basically, let's say if you were talking about the Google's popular V8 engine or a Chakra or a Spider Monkey, more or less the architecture is going to be same, so you don't need to worry much. Now here on the screen you can see that I have taken the top level view of a JavaScript engine, and later on in the next slide I will go into deeper that how these steps getting executed. So before that, first understand that what is this code, so from where this code comes. So this code is basically the code that is being developed by you for a certain functionality. So this code can come from the network, right? It can come from the cache, or it can come from the service worker or a web worker, right? So this code is a high level code. So this code comes from the network cache or a worker. Now it will go inside the JavaScript engine. So what is the purpose of JavaScript engine? The main purpose of JavaScript engine to generate the machine understandable code, and that machine understandable code is known as a bytecode. So the first it will go through the parsing stage. What parsing does? So in parsing stage, this all the tokenization and all happens, and this will generate the AST. So AST, what is this AST? So AST is nothing but abstract syntax tree. So abstract syntax tree is nothing but a kind of a binary tree. So this binary tree will go through this compilation phase. Though I have written this compilation phase, but in the actual it also goes through the interpretation phase. So it goes through this compilation or interpretation phase, and it generates the bytecode. though I will go into detail that how this compilation interpretation works. And this bytecode is a highly optimized or optimized code that can be understood by your machine and that can be executed out. So this is the top level overview that how JavaScript take a high level program and convert it into the bytecode and execute that. Now here a popular questions come. So what is that popular question? So suppose you were sitting in an interview and they will ask that JavaScript is a interpreted language or a compiled language. You will be surprised to know that when JavaScript language was created by the Brandon Eich. So Brandon Eich is the creator of JavaScript language. So at that point of a time he wrote a JavaScript engine, and that engine is now being utilized by the Mozilla Firefox, and that engine is SpiderMonkey. SpiderMonkey, he wrote that engine. So in that engine he only wrote the interpreter, means there was no compiler present. So this interpreter was there responsible for generating the bytecode. So at that point of a time JavaScript is interpreted language, right? But as the browser companies come into the competition, and there is a competition comes that we need to develop an engine which can generate a highly optimized code, and that engine is run very fast and all. So due to that competition we also got the compiler. So what that compiler does? So the compiler takes the bytecode that is being generated by the interpreter plus the type feedback that is being provided by the JS engine, and based on that it sends those two things into the compilation stage, and this compilation generates the highly optimized bytecode, right? But there is a scenario like we are using a function and there we were passing the argument 1 and 2. This is the integer, right? So first it will go at what type feedback will be provided, that the type is integer. So bytecode and integer will go to the compilation phase. But we also know that JavaScript is a dynamically typed language. It means that for the same function we can provide this 1 as a string and 2 as an integer, and due to that type correction and all it will behave like the same. But I am not going into that portion and all. So here we will understand that on JavaScript is a dynamically typed language. So here we can pass the argument inside the function as a string and 1 as an integer. So we saw that the type feedback has been changed now. So when the compiler will see that the type feedback has been changed, so what it will does is that it will ask the interpreter, hey, the type feedback is change, I cannot generate a highly optimized code. So interpreter will take the charge and it will generate the bytecode, and that bytecode can be directly executed by the machine, though this bytecode will not be optimized code, right? But that can be understood and executed by the machine. This whole process is known as the just-in-time compilation. So you got an idea that what is just-in-time compilation, and JavaScript takes the advantage of both interpretation and the compilation, right? And we can safely say that JavaScript is these days is now behaving as a both interpreted language as well as the compiled language, right? Now we will go into deeper and understand the internals of JavaScript engine. I hope you are getting my point. If you have any doubt, you can put it inside the comment. I will try to look after that and will provide a solution. Now here we will understand the component that is being involved inside that engine. As I have already mentioned that whenever you wrote a high level program that can be come out from the network, cache or a worker, and this program will come as a UTF-16 stream of byte or byte stream. Stream byte we will form this that will look like something. This byte of stream, UTF-16 byte of stream will go through a byte stream decoder. What this decoder does? So this will take the UTF-16 byte stream and it will create the token for that. So the tokenization phase will happen over here. and this token will go through the pre-parser phase and a parser phase, and this parser will generate the node based on the token, and this node will go further and construct the AST. You can see this is the AST. AST will basically being created from the nodes that is being returned by the parser. Now this AST will go through the interpretation phase, right? This interpretation, as I already told, this will generate the optimized bytecode based on the type feedback, right? Plus the bytecode that is being generated by the interpreter, compiler will generate the machine code or a highly optimized bytecode, and this bytecode can be run by the machine as well, right? So this is the overall thing that happens inside the JS engine. Though I am not getting into the details about accumulator, register and all, because that's a too much complicated thing, and I don't think that will going to come in an interview, or interview will going to ask. But if you are having the knowledge of those piece as well, then that would definitely going to help. So based on the audience, I'm just skipping that part. If you need to know about that, then I can make a video. Now let's go and understand the overall compilation pipeline of a V8 JS engine. This is the compilation pipeline of overall V8 JavaScript engine. So here, as I told, this is the ignition. So what this ignition is? Ignition is nothing but a name of the interpreter that is used by the V8, and this is the turbofan. This turbofan is nothing but a compiler that is being used by the V8 engine. Now over here you can see in the beginning of the pipeline, so we are getting this script text. This script text is nothing but a high level JavaScript program, JS program. This program goes through this parsing phase, though it will go through that byte stream decoder, then tokenization will happen, then it will go through pre-parser phase, then the parser phase, and after that parser phase the node will be created, and those node will go on and construct a AST, that is abstract syntax tree. Now this will go through the interpreter phase, means ignition engine will come into the picture, and this ignition engine will create the bytecode. Now this bytecode plus the type feedback, based on that this will generate, this turbofan compiler will generate the optimized code. Now on the runtime, suppose any type feedback is getting changed for any function, so it again a de-optimization step will go on, and in this de-optimization step what happen is that the bytecode that is being generated by the ignition engine, it will be taken and that will be executed, means that will act as a optimized code, though that would not be a highly optimized code, right? So in this way the overall compilation pipeline of a JavaScript V8 engine works. So here I have gone through a website, this is nothing but a AST Explorer. So this is the AST Explorer website is there. So there you can go and you can paste your snippet of JavaScript program, and that JavaScript program will give you the tree like structure, and that tree will be AST. So here I have taken a very small example, like I have declared a variable called LoveJavaScript, and this LoveJavaScript is having the value LoveJavaScript, right? So this will generate a top level node, that is the program. So a top level node called program will be generated. Now inside that program what we will get, that the type variable declaration. So again a node will be created, that will be a variable declaration node, right? In that variable declaration we are having again a variable declarator node. So this node will be a variable declarator node, variable declarator. Now this variable declarator again will be having a identifier phase. So identifier will be there, right? In identifier basically it will identify what is the name of the variable, that is the LoveJavaScript. After that we will be having this literal node would be there, and this literal node will be identify the value of that variable, that is the LoveJavaScript. Over here you can see that, right? So in this way this AST tree will be created. Now you might be wondering that I have wrote 1,000 line of a code, then this HT will look like a very long. Yes, of course this will going to be, look like very long, but thanks to the V8 engine that gracefully handles all this, and it's a super fast. So I hope you have got the crux of overall how JavaScript engine works and what is the internals of JavaScript engine, how the call stack work, how event loop and callback queue is there. So I hope you have got that. Apart from that, I also want to discuss a very small point, like in a callback queue, basically we are having the two type of a queue. First one is the macro queue, macro task queue, a macro task queue, and second one is that a micro task queue, micro task queue. So in macro task or micro, what is the difference? So difference is that the web API. So for an example, if we are having the API related to promise or an API related to HTTP network request, or API related to canvas or a DOM, right? So these API will go inside this micro task queue, right? And then it will be picked from the event loop. But the API is related to timeout, like set timeout or set interval. So these API will lie into this macro task queue, and this macro task queue will interact directly with the event loop, and that event loop will take the task and put inside the call stack. I hope you enjoyed the video. With this I would like to end this video, and if you haven't subscribed the channel, then I would highly recommend that you should subscribe the channel. And if you are preparing for a front-end interview or a back-end interview related to JavaScript, or your friend is preparing that, then I would highly recommend that you should share this series of videos so that they can understand and clarify their doubts. Thank you for watching Love JavaScript series.